we are on section 8.1, day 3 video, where we're completing the square. The first thing to do to complete our square is to move the constant to the other side. And I get y squared plus y equals 7. To find our c that completes the square, we have to take b divided by 2 and then square it. Our b is the number in front of this term here. If there's no number there, we always know that it's a 1. So 1 divided by 2, quantity squared, gives me 1/4, because 1/2 squared is 1/4. If I add a fourth to this side, I have to add a fourth to that side. So now I'm going to write this side as a binomial squared. To go from a perfect squared trinomial to a binomial squared, we have to take the square root of the first term, square root of the last term, sign in front of the middle term. And on this side, I get 7 1/4. I want to write it as an improper fraction because all these are improper fractions. So I get 29/4. Then we need to square root both sides to solve it. And I get y plus 1/2 equals plus or minus. Anytime you square root an equation, you have to put a plus or minus in front of it. And I'm going to split this into two radicals, square root of 29 over the square root of 4, but the square root of 4 is 1/2. Then I'm going to subtract 1/2 from both sides, and I get negative 1/2 plus or minus the square root of 29 over 2. Could we simplify that to negative 1 plus or minus the square root of 29 over just one common denominator? Certainly, but we don't have to. This is fine for me. The next one we're going to do is 45. 45 says 4y squared minus 12y minus 2 equals 0. First step again is to get rid of my constant. And I'm going to factor out the 4 out of both of these. So I have 4 times the quantity of y squared minus 3y equals 2. And I want to get rid of this 4, so I divide by 4, divide by 4. Now I have 1/2 over here. And I'm going to do the same thing I did before. Take my b divided by 2 and then square it. Well, my b in this case is negative 3. So negative 3 divided by 2 is negative 3/2. Squaring negative 3/2 gives me positive 9/4. And if I add positive 9/4 to this side, I have to add positive 9/4 to that side. Now that I have my perfect squared trinomial, I'm going to write it as a binomial squared. Square root of the first term, square root of the last term, sign in front of the middle term. And over here, I'm going to simplify to 11/4. 2/4 plus 9/4 is 11/4. Square root, square root. When I square root both sides of an equation, I have to add a plus or minus in front of it. So I have plus or minus the square root of 11, and then the 4 becomes the 2, because the square root of 4 equals 2. Then I'm going to add 3, and there's my answer. Could I write that as 6 plus or minus the square root of 11 all over 2? Certainly, but this is just fine. The next one we're going to do is question 48. We have 3x squared minus 4x equals 4. First thing we need to do is get rid of the coefficient in front of our squared term. So I'm pulling the 3 out front. If I'm pulling the 3 out front, I have to divide this by 3 also. Now, I want to get rid of this 3, get rid of the 3, and I get x squared minus 4/3 x. Now, to get my c over here, I have to take negative 4/3 divided by 2, that's b over 2, and then square it. Well, I need my calculator a little bit to simplify here, so I'm going to take negative 4/3 divided by 2 gives me negative 4/6. Negative 4/6 simplifies to negative 2/3. And 2/3 squared gives me 4/9. And if I add 4/9 to this side, I'm going to add 4/9 to the other side. Now I'm going to write my perfect squared trinomial, because we've completed the square. It has to be a perfect square trinomial now. So I'm going to take the square root of the first term, square root of the last term, sign in front of the middle term, and that's going to be equal to, let's get a common denominator over here, times 3 to get my common denominator, and 12 plus 4 is 16/9. So when I square root both sides, I get x minus 2/3 equals plus or minus. The square root of 16 is 4, the square root of 9 is 3, and I'm going to add 2/3 to both sides. So I get 2/3. Because there's no square root or I, we need to split this into two answers. So here's my two answers. 2/3 plus 4/3 gives me 6/3. And 2/3 minus 4/3 gives me negative 2/3. Well, can we do some simplifying on this? 6/3 is the same as 2. So I'm going to change 6/3 to 2. There's your answers. Let's jump to number 51. We have x squared plus 8x plus 1 equals 0. This one's a little bit easier. Let's get rid of this 1 first. My first step is to get rid of the constant. And I get x squared plus 8x equals negative 1. Half of 8 is 4. 4 squared is 16, so I'm going to add 16 to both sides. Write it as a binomial squared, square root of the first term, square root of the last term, sign in front of the middle term, equals 15, square root, x plus 4 equals plus or minus square root of 15 minus the 4. And because we have a radical over here, we would leave it like that. On to 54. 54, I have 2y squared plus 12y plus 3 equals 0. Again, moving the constant to the other side and factoring whatever is in front of your squared term. Oops, so y. And on the other side, I get negative 3. I want to divide by that 2, divide by the 2. Half of 6 is 3. 3 squared is 9, so I'm going to add 9 to both sides. Then I'm going to write this as a binomial squared, square root of the first term, square root of the last term, sign in front of the middle term. And on this side, I get 7.5. Most of the time, we want to write it as an improper fraction. Remember, your calculator with the DC function will do that. But if not, we can take 7 times 2 is 14, plus the 1 on top gives me 15/2. Then we can square root, I get y plus 3 equals plus or minus the square root of 15 over the square root of 2. Then we're going to subtract 3. The problem with this is we can't leave it like that because we have a radical in the bottom, so I have to multiply top and bottom by the square root of 2 to rationalize that, which gives me negative 3 plus or minus. Square root of 15 times the square root of 2 is the square root of 30, and on the bottom I get 2. Now, could we write that as a common denominator over the whole thing? Yes, we can, but this is also a correct answer. And let's move up to number 63. 63, we have 5x squared plus 15x minus 1 equals 0. And I'm going to add 1 to both sides, get rid of the constant. And I have 5x squared, 5 times the quantity of x squared plus 3x equals 1. Half of 3 is 3 halves. Squared gives me 9/4. And I'm going to get rid of this 5. And I'm going to then add the 9/4. So I'm going to write this as a binomial squared. Square root of the first term, square root of the last term, sign in front of the middle term. And on this side, I need a common denominator, so I get 45 plus 4 gives me 49 20ths. And you can use your calculator to get that. Square root, x plus 3 halves equals plus or minus 7 over 2 root 5. And then I'm going to subtract the 3 halves, subtract the 3 halves. I get x equals negative 3 halves plus or minus 7 over 2 square roots of 5. We have to rationalize square root of 5, square root of 5. Then when we do that, we get x equals negative 3 halves plus or minus 7 square roots of 5 over 10. Good luck!